y'all, so the website I made this video on was not working properly, so I am just quickly making a new one. So, number 1 says draw a circle around all the words that mean X values and underline all the words that mean Y values. Well, X values are what you put into a function, and Y values are what you get out of the function. So your input is your X values, and your output is your Y values. Now with range and domain and range, you can think of it this way. The X axis is the long axis, right? And domain is the longer word. Domain is your X values. And now dependent and independent variables, you probably learned about these in science class, right? Your independent variables are what you choose to change in your experiment, and your dependent variable is what happens because of the change. So your independent variables are what you put in to your function, your inputs, your X values. And that means that the rest of these are Y values. You get out your Y values in a function. The range is the Y values of your function. The dependent variables are dependent on your X value. And f of X is another way to say Y. So now how can you tell if a relation is a function? Basically, if you're looking at a bunch of points, if the X values don't repeat, if X values don't repeat. If the X values don't repeat, you have a function. Or if you're looking at a graph, if it passes something called the vertical line test. So if I were to draw a vertical line through this graph, it would touch it twice. So this does not pass the vertical line test. So a vertical line only touches once. So let's check these out. Is the following a function? I see this X value of 2 repeats. So no, this is not a function. Is this one a function? Well, I see a 2, a -2, a -3, and a +3. I see no repeating X values, so this is a function. Even though these Y values repeat, you would have a graph that looks something like this, just a horizontal line. Number 5, is this graph a function? I can draw a vertical line anywhere on this graph, and it'll only touch one time. So yes, it's a function. And number 6, is this graph a function? If I were to draw a vertical line through this graph, it would touch twice. So no, it is not a function. Moving on to number 7, create a table, a mapping diagram, and a graph for the function f of x equals 2x plus 1 with a domain of -1, 0, and +1. Well, we already decided that domain is our X value, so the first thing I'll do is put in my X values. -1, 0, 1. So these are our inputs. This is what we're going to plug in to this function, and we'll get out our outputs. So if I plug in a -1 for x, 2 times -1 is -2, plus 1 is -1. 2 times 0 is 0, plus 1 is +1. And 1 times 2 is 2, plus 1 is 3. Now over here with my mapping diagram, I'm going to do something similar. I'm going to put all my X values on the left, all my Y values on the right, and I'm going to draw arrows from my X values to my Y values. So I have -1, 0, and 1 are my X values, and -1, 1, and 3 are my Y values. And I don't have an arrow function, so I'm just going to draw a line here. But my X value of -1 goes with my Y value of -1. My x value of 0 goes with my y value of 1, and my x value of 1 goes with my y value of 3. And now if I were to graph it, I would use this table as coordinates. So this point would be -1, 1. So -1, I'm sorry, -1, -1. -1, -1, boom, put a point. 0, 1 is, let's get this off of here. 0, 1, boom, put a point. And this last one is 1, 3. So 1, 3, boom, put a point. And then I would connect the dots, but I can't do that in this program, so we're just going to pretend that this is me connecting the dots, and we have a line. Moving on to number 8. A farmer wants to use 500 feet of fence to create a pasture for his horse. The area created by this is modeled by the function a of w equals 250w minus w squared, where w represents the width in feet. What is a of 50? See how over here I see a of w, and here I see a of 50? That means that we're going to take this 50 and plug it in anywhere that there's a w. So a of 50 is 250 times 50 minus 50 squared. And if we did this math, we would end up with 10,000 feet squared. Number 9, which of the following are not a function? Circle all that apply. I'm going to put the circles above so that you can actually see what I'm doing. But see, I have a -2, a +3, a -5, and a 7. I see no repeating x values, so this is a function. I'm sorry, this is a function. This one I see -3, -3, +5, and +5. Notice I have repeating x values, so this is not a function. -1, +2, -3, and +10 do not repeat, so this is a function. And this guy has all -2's as x values, which are repeating x values, so this is not a function. Moving on to number 10, based on the data gathered by the U.S. Census Bureau, the population of the United States is shown on the graph to the right from 1900 to 2010. The equation that best models the data is P of t equals 81.166 times 1.013 to the t power. What is the domain of the graph of P of t as shown? Well, check this out. The way that this graph reads, this y-axis, your range, is the population in millions, and this x-axis, your domain, is years since 1900. Notice this graph is going up by 20s. So on your options, all of these are relevant to this graph, but we are specifically looking for the graph of P of t, which is the line itself. It's not the dots, it's not what the graph is representing, it is the line itself. So the domain of the line itself is all of the values in between 0 and 110. So your answer to that one is B.